So here's an example of a table, and in the question it states that 13% of students are computer science majors. So let me just call that CS in parentheses over here, and it says 13%. Well, so that's the probability of a computer science major, which is the marginal probability. So that goes in the margin of computer science. 15% have taken discrete math, and that's event B. So we'll call it discrete. And 15% is going to be the total for that distribution over here. And then we have 84% of students are not computer science majors and have not taken discrete math. So if we use, our letters over here, not computer science, that means A complement, and not discrete math, that means B complement. So this is one of our joint probabilities that goes right here at A complement and B complement. This is all we need in order to fill in the complete contingency table over here. Because one thing we know is that our probabilities always add up to 1. So if the probability of computer science is 0.13, well, that means there's 0.87 probability that someone is not a computer science major. If someone has a probability of 0.15 of taking discrete math, then they have a probability of 0.85 of not having taken discrete math. Then we fill in all the other ones. Well, if this is 0.48 and the one next to it is 0.85, we just have another 0.01 over here, which gives us 0.12 over here and 0.03 over there. So now whenever we're going from left to right, we end up with the totals on the right, and when we're going from the top to the bottom, we end up with the totals on the bottom. So oftentimes when we have a question given like that, it's a really quick and easy thing for us to put together our contingency table, and then we can use that to answer questions. So the question we are actually trying to answer is, what is the probability that a student is a computer science major but has not taken a course in discrete math? And just to translate this, we had a computer science major and not taken discrete math. So but is just another word for and, as I mentioned before. So computer science is A, not discrete math is B complement, and we're looking for that joint probability. So what is the probability of A and B complement? Well, it's given right here in our table. Where A and B complement intersect. So that probability is equal to 0.01. So what is the probability a student has taken discrete math but is not a computer science major? Okay, so over here we are looking for discrete math, which was B, but not a computer science major, that's A complement. So again, on the table, it's very easy for us to see B and not computer science is right over here at 0.03. The next question is asking, what's the probability that someone who has taken discrete math is a computer science major? So slight distinction over here. Before we had and really it was written in the form of a but over here, despite, it's still a joint probability. This question is asking a little different. What's the probability that someone who's taken discrete math is a computer science major? So we already know that the person is taking discrete math. So we are looking at just the first row. This is a conditional probability. It's the probability that someone is a computer science major, which is A, given that they've taken discrete math. So very careful. Someone who has taken discrete math. This tells you right here that this is conditional. So remember how we find that probability. We're going to find, or we're going to use the joint probability in the numerator, and we're going to use the marginal probability in the denominator. So over here, the probability of A and B is 0.12. The probability of B total is 0.15, which is a probability of 0.8. And let me just remove kind of this part of the writing over here to make it a little cleaner. All right, so conditional probability. The next one is saying, what is the probability someone has taken discrete math or is a computer science major? So what is the probability that someone has taken discrete math or is a computer science? So discrete math was B, or is a computer science, that's A. So we're looking at A or B. And for A or B, we can either add in such a way that nothing is counted twice. So if I wanted to highlight, maybe with a different color over here, we could highlight everything that's A. So over here, we could highlight everything that's B. And then we have the choice. Do we want to use the totals on the table and count in such a way that nothing is counted twice? By either taking the discrete total and then adding the computer science one, or do we want to use the marginal probabilities and subtract out the duplicates? So either way, whether I take the total of the discrete ones, which is the 0.15, and then I add what I have not counted yet, which is the computer science majors that haven't taken discrete course. So that would be one way to find the probability. Or I could take out totals and calculate it as 0.15 plus 0.13 minus 0.12, which is also 0.16. Using that probability formula, the addition rule in the second way over here, or if I wanted to just intuitively use the table, I can do that as well. So or probability always indicates that we're adding together. And then the last question over here is asking whether discrete math and being a computer science major are independent events. There are two ways for us to check that. Usually it's a little easier to look at the joint probabilities, but we can also look at the conditional probabilities. So when you're checking this, you don't have to use both methods, but I'm going to write them both down. So method one, we are going to look at the probability of A and B, and we're going to compare that with the probability of A times the probability of B, and we're going to see if they're equal to each other. On our contingency table, when we do that, is we simply take our marginal probabilities, we multiply them together, and we check if we end up with a joint probability. So we would do 0.13 times 0.15 and check if that's equal to 0.12. So 0.12 was the joint probability, and is this equal to 0.13 times 0.15? Well, you will see that that is not equal to each other, and therefore we know that we can cross this out and say this is not independent. No, they are not independent. Being a computer science major is not independent from being haven't taken discrete math. In fact, they are dependent. So this is method one. Method two, we're going to look at the conditional probabilities. Usually a little harder because it involves having to find those conditional probabilities. So we could check, is the probability of A given B equal to the probability of A. So if it was independent, then the fact that B already happened would not affect the probability of A. So the probability of A given B, well, we found that above, so we can use that as 0.8, and this is not equal to the probability of A, which is 0.13, which was that marginal probability. So over here, since we had already calculated the conditional probability, it's easy for us to compare it with the marginal probability. And therefore, we can say, oh no, they are not independent. In fact, they are dependent because, and then use one of these explanations. So again, you can either use the explanation that the probability of A and B is not equal to the probability of A times the probability of B. Or if you would rather use method 2, then you would say they're not independent because the probability of A given B is not equal to the probability of A. So both methods work. They're equally good. So use whichever one you prefer.